All right, first thing. Is this on? Did I hit? Oh, nailed it. All right, I want to. I'm not gonna update that yet. So I know several of you have asked me about whether there's tutoring opportunities and things like that for this class. There really isn't, but this is I know some of you are already doing this, and my guess is most of you who are doing this did much better on the exam than some of the people who are not doing this. I really, 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 really encourage you, and this isn't the first time I've said this, I said it the first week of class, get into a study group for this class. Find 2 or 3 other people in this class that are also struggling, or if you're somebody who's doing well in here, you will get even better at programming by helping 2 or 3 other weaker students learn this stuff, because when you teach it, you get better at it because you're finding new ways of kind of explaining it. And sometimes students learn better from other students than listening to the teacher say it, or when I go through it and do it too quickly, because then you have to go back and reprocess it or something like that. So the more different ways you can hear the same material, the better. All right, so what I would encourage all of you to do, if you're interested, actually I encourage all of you to be involved in this, regardless of how well you did in the exam. Go ahead and go to the Slack channel, post on Slack that you're looking for a study group, and there hopefully will be 10 or 12 people who are up there, and then start meeting up to work on homework together. Those of you who are already working on homework together, you're noticing I'm not flagging you for cheating and things like that. I'll find out in the exam whether you're learning stuff. Right? So work in groups, find a couple of buddies. Best bet is maybe get 2 or 3 weaker people in a group with maybe a stronger person. And I really encourage the people who did well in the exam to maybe offer up their help on Slack and say, hey, I'd be interested in doing homework with you guys, and that way you can kind of help them learn and then make you even better in the long run. So it's beneficial for everyone. But do take advantage of something like that. Frankly, that's way more valuable than going and getting a one-on-one tutor who's going to sit there and do the little teaching thing and say, well, what do you think the answer is, or something like that. At the end of the day, the goal shouldn't just be to get your homework done. Hopefully some of you have seen when you turn in an assignment and you give me one of these things where I spent 9 hours on this. Based on effort, I should get an A. Based on my solution, I should get an F minus, 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 minus. Okay? Okay? You get a better grade than an F minus, 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 minus. All right? I'm giving a lot of credit for that effort. I'm going to find out how much you're learning on the exam. Because during that 9 hours, even though you didn't succeed at what you were going for, you learned a whole bunch of crap. At the very least, you learned a bunch of stuff that doesn't work. Okay, right? Now, the other thing I want to strongly encourage people against doing, and I realize this is easier said than done when you're kind of just getting started, but try not to approach programming assignments through the trial and error approach. Okay, where you write something, it doesn't work, and then you just start randomly changing things. All right, and try it again. And then eventually it just works, but you have no idea why it works. It's like, okay, well, it works now, so I'm going to turn it in, and I got my points. Okay, but now it's cost you on the exam later on because you have no idea why that worked. You just went through every permutation of things you can type until it finally gave you a solution that looked right. Make sense? So whenever you make a change to the code, at least have it be based on an educational guess, or an educated guess. Like, I think this is what I need to do. I'm not necessarily sure even what this means, but let's see what the result is when I change this. Do a lot of little experimentation when you're writing your code. I promise over time, things will start taking less time. Your homework will always take a long time because I'll keep giving you harder homework assignments. Okay? But the old homework assignments that took you 10 hours before will only take you 15 minutes. Then you'll have a new 10-hour homework assignment. So it's just joy for 4 years. 4 years of. Okay? But good news is when you graduate, you can go make good money. So it's payback. So 4 years of hell. Okay. 5 years if you go and get a master's, which I have encouraged most of you to. I've mentioned in class before. I think that's a smart thing to do today, just because the bachelor's degrees become the new high school diploma. It's unfortunate, but it's just the way the world works. So, spend the extra year, get a master's, stay poor for as long as you can, rack up those student loans, then go out and get a good job. If you notice some of our things in the hall, if you do some research, you'll see that jobs in computer science pay substantially more than jobs in almost any other field. We're talking doctor, lawyer level type stuff. If you get a good job in the industry, your student loans will not be an issue. All right, you'll pay your $500 a month, but you're making $140,000 a year, or something like that. If you're living in one of the coasts, you come right out of school making 65, day one, and then you're going and doing something else, and by year 5, you're making $100,000. Yeah. Yeah. So what we definitely allow in our program, if you do our program here, we have our master's in computer science is 6 courses, each 6 credit hours. You can definitely take one of those master's courses. You have to kind of prepare early because you have to take pretty much 18 credit hours every semester because you have to give yourself a 6 credit hour hole somewhere as like a senior to take one of those master's classes. We have in the past done up to 2. I don't want to promise that, but that's a possibility. But 1 is definitely a thing. Our master's program, the way it works is it meets the classes, there's 2 per semester. There's 6 total classes. They meet in the evenings, 1 day a week. So a class meets from 6 to 10 p.m. on a Thursday night for the full semester. So you could still be working. You could be out in industry doing your job and stuff like that, and then 1 night a week sucks. Or if you're going to do 2 classes per semester, if you want to get done quickly, you want to finish in that 1 year instead of dragging out for 2 years, taking 1 class at a time, 2 nights a week suck, right? And then you also have homework and things like that. But it'll just pay so much dividends in the end when it comes to salary and upwards potential and jobs and things like that. It didn't used to be that way. We roll back to late 90s or early 2000s. People were getting signing bonuses coming out of bachelor's degrees in computer science. It was really interesting. It doesn't even exist anymore. The companies were competing for the students. So, almost like you hear professional athletes being recruited. Company X would offer you a $20,000 signing bonus. Company Y would offer you a $15,000 signing bonus. You would pick the one with the bigger signing bonus, right? This is just free money. Like, here, we'll give you this money if you agree to work for us. It doesn't work that way anymore. Okay, because now everybody goes and gets a college degree, and a lot of people are in technology. So now the students are much more competing for those jobs. But now when you get to a master's degree level, now all of a sudden you rise to the top of the stack for resumes. Now you might still come in at the same base salary, but you'll get that job. And then you'll notice we had a student, his name's Nick Largent, if any of you knew him. He works for Northwestern Mutual. He just started working there last year. I think came in around 58 or something like that. Just got a promotion 1 year later. He's making 89, plus like a bunch of benefits. This is 1 year later. And he was one of our better students. This is a guy who went to all the hackathons. He was one of those students that worked with study groups, led the study groups. He was the stronger programmer, not our strongest programmer, but stronger. So there's a lot of upwards potential, but you got to find a way today to set yourself apart from the thousands of other students who are applying for the same crap. It's an unfortunate reality, but we live in a society now where everybody thinks they have to go to college. And then what's happened now is we have a shortage of electricians and plumbers and skilled labor that we need. If we don't have electricians, our electricity will stop working. Okay, so I have this PhD in computer science. My wife won't let me touch electricity. I don't know what I'm doing. Okay, we need smart people like that who can work with electricity, right? But those people are going to college now because society says they should, instead of going to a trade school or an apprenticeship or something like that where that's where their skill is. It's unfortunate, but that's the reality. So, deal. Well, possibly that's a little dangerous though, because you got robotics and electricity. A little short circuit, you got an issue. You got this dead robot. you got to drag him off. Oh, speaking of which, cool stuff. If you're interested, I haven't even seen the machine yet, but Dr. Wall just got a new toy. Well, the department got a new toy, but Dr. Wall is in charge of this particular kind of toy. We already have a bunch of 3D printers, right? Mm-hmm. We just got a new one yesterday, and it is ridiculous. I think it can do. I don't know the exact size. I think it might be like 2 feet by 2 feet by like 4 feet. I mean, so you could print big things.
Yeah.
This thing, where most of them can print kind of small little things. It's like a $9,000 printer. Totally legit. Yeah.
Is it one of those liquid printers?
We have one of those. Oh, that's 2 years ago, dude. Come on. No, the liquid printers, those things that they're not necessarily about the size. In fact, most of them, they actually make smaller stuff. That's resolution. They print very high definition things. So if you need a part that is very detailed, they print that type of thing. Material's a lot more expensive. The printer's a lot more expensive, all those things. But if you need something like that, if you need to just throw together like, our holders for the controllers for the Vive, you print that thing on the lowest resolution on the cheapest printer and you just wait for a day for it to finish printing. No problem. It doesn't need to be, and you pick your ugliest color of spool of the printing, the plastic stuff. It doesn't matter because that doesn't need to be precise. But if you have like a screw, like a very specialized screw you need for a part for something, and you need to make it with a very specialized material and it needs to be like perfect. Can't have like little bubbles and stuff on it. You would want to use a higher resolution printer for that. But we did get another cool printer in the department, so that should be exciting. So now we need to find something giant to print, like a boot or a helmet.
Yeah, you can do a helmet there.
Well, it was a couple of years ago, Dr. Wall, and I'm still upset with him about this actually. He was supposed to make Mr. Gonzalez a present. He was supposed to make Mr. Gonzalez a Packers helmet. And he 3D printed one of these, spent some time doing it, and then when it was almost done, he dropped it and broke. And then he never replaced it. Just gave up on the project. One of his greatest failures.
So now you want a full-size one for yourself.
No. Mr. Gonzalez wants a Transformer suit. Is what he wants. All right. So yeah, a lot of information about your future there, but as it pertains to this class specifically, anybody who thinks they need some extra help in this class should go on to Slack today and post up there that you're looking for a study group. And I encourage you to get into one of these groups, even if you don't perceive you need help. Things are just going to get harder. And who cares if you're the all-star in the group? Because part of being a good programmer ends up, you end up becoming kind of cocky. It's a thing. A lot of times what I have to do is that when they're like juniors, the really strong people in the program, you almost have to have a discussion with them to back them off. Because, it's kind of like when you're on a sports team and you're like the best player on the team, and all of a sudden you think you're better than everybody else. But you still have your weaknesses that you don't necessarily see, right? But you're just good at certain things. So if you start seeing yourself get cocky, you think you're better than everybody else in programming, stuff, that's good. But try to, what's that?
I said that's a good thing.
That's a good thing from a self-confidence perspective. Maybe a bad thing in the long run. All right. Questions about any of that stuff? If you have any questions about the master stuff, talk to me after class or something sometime or whatever. I encourage everybody to at least consider that. We also have a master's in information technology, if you're more on the IT side of things, that also meets in the evening, but that one has more classes, but they're only 3 credit hour classes, so they meet for 8 weeks. So similar program, you just have more individual classes, but the same amount of classroom time. Okay, I'll just say post on Slack here. Now, let's see where we left off. What class is this? 200?
Yes.
Got the eye thing going on again. Just my left eye. It's not seeing good today. It's old age, dude. Don't let this happen.
Just don't grow old.
Yeah. If you can help it, don't grow old. Things start breaking. Yeah, that's not what I'm doing. Okay, so we've done, well, here I can actually do, well, let's see where we're at. So we've done through functions.
Yes.
We've done strings. we've done lists and dictionaries, but maybe haven't necessarily really drilled those heavily. Now, remind me, did we do any sorting of a list? Did we write?
No.
Okay. I think I make some reference around the exam about some variable called the follower, and everybody gave me the blank look. Yeah, there's an algorithm I teach for sorting, and there's this variable that I called the follower, and you say it creepy like the follower. Yeah, but I think I mentioned it during the review for the exam, and nobody knew what I was talking about, so we must not have done sorting. So why don't we look at something like that? Have we done random numbers?
No.
Killing me, people. All right. So let's do some stuff. I think it's called randint, but let me get the library for it. Random. Yeah, randint. AB, and I need to import random at the top, I think. Okay. So let's get some random numbers going. How about that? Kill off some of these things. This is us, right?
Yes.
All right, let's kill this. Unimportant stuff, right? Okay, so at the very top here, I'm going to import something called random. Actually, I'm not going to import it at first. That way we can see the error. And then I'm going to go ahead. I'm going to say print random.randint 0, 10. And why don't we actually go ahead and do this inside of a loop? So I'm going to say for I in range 0 to 100, we'll print out a random number between 0 and 10. All right, that's what we're going to try to do. We'll give ourselves 100 random numbers just to see how randint works. All right, now is this the, you like this?
Choo-choo.
That was a question on the 450 exam where you had multiple threads, multiple processes running, and so you had a bunch of child processes that would get forked, and then so all the children are saying checka 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 checka, and then the parent sleeping at the very end. The parent goes choo choo. See, that was one of those questions of what does this code do?
Oh, really?
On their exam, yeah.
Nice.
But this part was made by a different process. This part was made by a different process, like a different program.
Okay.
This part was made by a different program, so on and so forth. And the choo-choo was made by the original program. So the parent kept creating child processes that do all these things on the side. That way you could have more than one program running at once and that kind of stuff. So it's actually complicated code, but the output is funny. Let's see, CSC200 is this? Yep, that's our Python 3 CSC2. Oh, yeah, that's right. I was telling you that so you can see the error, right? Okay, so this is telling me it has never heard of random. So I need to go back in here and I need to, at the top, I need to import the random library. That way I have access to that dude. Okay, so you see here we have 100 pseudo-random numbers. The smallest number we see in here is a 0. We do see some 10s. So that means if you look at our thing here, the randint, this gives me a number between 0 and 10 inclusive. So it includes the 10 and it includes the 0. Okay, if I want to change this to give me a number between 1 and 100,000, this will generate a random number. They're usually called pseudo-random numbers because true forms of randomness are actually difficult to come by. So a random number generator in a computer is considered mostly random, but not necessarily fully random by mathematical standards. It should be very random for our purposes. All right, so now we'll have 100 numbers between 1 or 0 and 100,000. All right, make sense?
This is basically a dice roller.
Well, not a dice. Well, I guess technically we've rolled a 100,000 sided die 100 times. So sort of kind of a dice roller, I guess. Have we done objects in here yet? No objects, just functions, right? Okay.
I remember you showed us a program that had a
His program.
Yeah, we'll write that pretty soon. That'll probably actually be next week. If we haven't done objects yet, the next step is this, and then the other thing, and then objects. The objects is the next thing. That's the big thing. Objects is the big thing, important thing, not a hard thing. Just one more wrapping. Remember when we talked about the procedural telephone versus the object-oriented telephone? We said the object-oriented telephone looks like a telephone, okay, as opposed to the big pile of wires. Right now, all our programs have looked like a giant pile of wires, right? We've had function and function and function with all this logic all over the place. Well, when we get to objects, you're going to have a lot of that logic up here, but it's all going to be housed inside of an object. And then down here, you'll just create one of those objects and use it. Be much nicer to work with and allow you to accomplish more complex things as well. All right, so now instead of printing 100,000 or 100 random numbers, let's go ahead and fill this stuff into a list. All right, so we're going to say my list is equal, I'm going to start that guy off as the empty list. So it's a list that has nothing in it. All right, so remember, lists are the square brackets, dictionaries are the curly braces, right? Those are the two different dudes that we are working with. So, but this is going to be a, we'll talk about dictionaries in more detail right before objects. It's kind of like the predecessor to objects in the big scheme of things. All right, so I'm going to give myself an empty list, and now I want to take each of these random numbers, and instead of printing them, I want to add them to my list. So I'll append to my list, a number between 0 and 100,000. And I'm going to do that 100 times. So that should take my list, which starts off as a length 0. Actually, somebody want to hit the third button down back there just so you can see the screen a little bit better, especially the folks in the back. Thank you. Is that better? I still can't see. But you guys are in a better.
Just the up one, right?
Is that confidence building? Your teacher sitting in the front and they can't see the computer screen?
Maybe it's just age.
It is. It's definitely age.
Are you sure it's
Maybe it's actually demoralizing though. Since some of you didn't do very well and things like this guy can't see the screen and he can write the oh. All right. So we're going to start off with this empty list. There's 0 elements in there. After the first time through the loop, the list has 1 element in it. Next time through, that list has 2 elements in it, 3 elements, 4 elements, 5 elements, so on and so forth. Make sense? So if I were to print out this list before, print my list, and what's nice about Python versus some other programming languages is you can print out structures like lists simply like that. It has a built-in format for kind of showing you a quick view of the list. It might not be your ideal view of it because it puts it all kind of, with character returns on line, but, chunked together. But it does make it convenient if you just want to look at the list. Where in other languages, if you were to print out a list like this, it would give you a memory address. So you would actually have to write a loop that goes through every element of the list. And I'll actually show you that here in a second. I'll show you the alternative. It's not that bad. But I'll go ahead and print out my list after I fill it up with some random numbers. All right. So let me do a little print before. It'll take me longer to, then we'll do a print after. All right, so we're printing out the same variable, but before and after our loop that fills it up with some stuff. So here's my before, empty list. Nothing in there. Here's my after, list with a bunch of crap in it. Now I've counted those exactly. There's 100 elements in there. Can't see, but I'm very fast at counting. Exactly 100 elements. Here, and here, we'll prove it.
There we go.
I did try to hit that curly brace, but I must have hit the 100 elements. The length of that guy is 100. So we're good. All right, now in an older program, well, not even an older programming language, in the many other programming languages, specifically strongly typed, compiled languages. Rather than being able to just print out my list like this, I would have had to do something like for I in range 0 to length of my list, print my list at bucket I. Something like that. And this will put it one per line, but it will, I can actually make it not print one per line. There, let's do it one per line first, then I'll show you the other thing. I'll ask you what the other way would be. So rather than just saying print, I have to go through each element in there and print that single element out. So there's my 100 random elements. That's in my after. Now, if I want those guys squished together, how could I modify this code right here to not show them all on one line each, based on what we've learned in here so far? What's this? Yeah, that end thing. So we haven't used it a bunch, but this little thing, end equals, well, I think you can actually do that. Something like that. We'll put a little, just a space, or if we wanted to, you could put a comma or something like that. Now there's your spaces version of it. Make sense? Okay, so questions about the kind of the generic elements of a list. So this is how you create an empty list. This is how you add things to a list. This is how you access an individual element of a list. Now let's say that what I'm going to do is I'm going to go ahead and say my list at bucket 0, which is the very first element of the list. I'm going to set that guy equal to a -5. This is how you can change the value at an existing place in a list. Okay? So there's bucket 0 is a -5. And we know that guy's been changed because we were generating random numbers between 0 and 100,000. -5 wasn't in there. So I have gone through and I've modified one of the elements that already existed in my list. All right? And we do that using this syntax.
Can you edit multiple levels of the list?
Edit multiple levels of the list. What do you mean by that?
So could you put like you can find multiple areas in the list?
Oh, sure. I mean, I can. So you want to do here? Well, why don't we put it at the very end too? That's the last legal bucket in the list, right? The length of your list -1 is the last legal element in the list. So that guy, what I have highlighted there is going to boil down to a number, correct? The length of my list is 100. 100 minus 1 is 99. The legal buckets in a 100 element list is 0 to 99. This is that whole don't judge a book by its cover. Because you might look at this and say, oh, I'm dealing with a list. And your mind immediately says, list stuff. But because we're using the length function, that dude's a number. That's how many elements are in the list. All right, so this will give us a -5 in the first and the last element.
Oh, it wants parentheses instead of brackets.
Where did I give it? Where am I? My list is
Length.
My list.
Oh, length is not a yeah. That guy's a function, not a list. He was testing and you failed. -5 there and -5 here. First and last. You can change anything you want in there. Similarly, I can say my list. Actually, I'm pretty sure I can do this in Python 3. So I'm going to set my list at bucket 100, which did not previously exist, equal to -100. I think this will be equivalent to appending a -100 on there. Let's see if that works in Python 3. Nope, index out of range. So if I want to add something to a list that already exists, I have to append it. A who?
You need to have the negative one
Up here?
on the second one.
No.
Well, no, because I'm trying to add a new
Oh,
element.
okay.
Yeah, the legal elements in my original list of 100 is 0 to 99. I'm trying to put something at bucket 100, which did not previously exist. So I would have needed to say my list dot append. The negative 100 to put one more element on there. Okay. Let's look at a couple other fundamental things here. So I'm going to go ahead and I'm going to get rid of all those little, well, I'll leave them there just for now. It's fine. I'm going to go ahead and change my random numbers back to 0 through 10. That way we should have plenty of duplicates of several of them. All right, so we'll run this again. We'll see that we have smaller numbers now. All right, except we still have our couple of -5s and the negative 100 we slapped in there. So now what if we want to remove all the number 10? So look at your book. Let's see what function they're using for remove in your book. It's probably just dot remove. Modifying lists. I want to use the same function because there's usually several functions you can use.
Dot remove on the bottom of the highlighted.
Who?
There's a dot remove. Right where your cursor was.
Stop it. Right there. Right there.
I see it. I see it. All right, so is that funny? All right, so now, all right, so now what I'll go ahead, we'll print it out, and then I'm going to go ahead. I'm going to say my list dot remove, and let's remove 10. All right, this will go through and remove all the 10s from my list. Is what I believe it will do. All right, so here was our original. Now, notice here, why does it pick up right here? Hold on, that guy still has 10s in it. Did it just remove at index 10? It's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is a 1 there. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, it removed from bucket 10, not removing the 10s. So remove here removed element number 10 from my list permanently. There is a function, a list function, let's see if the book covers it, that will do a remove of a certain element. Otherwise, we can just write that. It's not the end of the world. Oh, this is kind of a fun way of going through every element of a list. Let me cover that here real quick too. So we're kind of adding stuff to our toolkit, right? So down here, when I'm looping through every element of my list, I'm saying for I is in range of 0 to the length of my list minus 1. And then to access individual buckets of my list, I'm using that index to get me that element of the list. Mm-hmm. Now I'm going to write that very similar code again. So we're going to say for val in my list, print val and is equal to the space. These two guys will have the same outputs. Let's go ahead and prove that real quick. All right, so there's that's the first time I printed. That's with the, for I in range. And here's the second time I printed. That's for val in my list. All right, so we got the same output. So this guy produced identical output to this guy. What's the difference between these two? What do I not have access to in the second for loop there? In most programming languages, this second for loop type here would be called a for each loop. But in Python, they just kind of all mix together. You don't have a special syntax for it. As you see, they're all the kind of the same syntax. But what do I lack in this second one that might be beneficial depending on the problem I'm trying to solve?
The second one, you can't choose how long to loop, I guess.
Well, I am. Indirectly, I am, because I'm saying I want val to be equal to every single element in my list. So the number of times you're going through is the number of elements in my list.
Right.
So you're indirectly getting it. But you're right from the perspective of I could choose up here to say I only want to go through bucket 5. Yeah, I don't get that option in the second one. So that is a true statement. Not necessarily what I was looking for, but definitely a true statement. I get to choose if I want to partially go through the list. Up here, we're down here, it's an all or nothing thing. What else do I not have access to down here? Somewhat related to what you said.
You can't choose which one it prints. I mean, it'll keep printing the next one.
Yeah,
What.
I don't have that index of where the guy I'm currently looking at lives.
Mm-hmm.
I don't know that I'm looking at bucket 7. I just know I have the next value in my list. Now, that might be okay. If you're just going through and printing what's in the list, who cares what bucket you're at? You might as well have this kind of shorter version of this, right? Who cares? But if you actually need to know what bucket you're at, maybe you want to remove the element in the list, right?
Mm-hmm.
You want to remove that guy. You kind of need to be able to tell the remove function which bucket you want to remove. So you got to have a counter. Now, I could give myself a counter down here. I can say, j is equal to 0, and then after each print, I can say j is equal to j plus 1. So I can artificially add a counter in if I'd like, right? Just say, well, I'm going to make j just track my for loop here so I can keep track of where I am in my list. And that would be okay. But you do lose that granular control. Now, that doesn't mean one is necessarily better or worse than the other. What it dictates is which of these you might use in different circumstances. Make sense? If I'm just printing the contents of a list, why not make your life easier and not have to write this little index type syntax here and give yourself this range thing here, having to know where the end of the list is? Those are all things you should know. But why do the extra couple of steps of typing when you can just use the for each loop and just say, each time through, I want val to be the next element in the list. Make it happen. Under the hood, it might write something like this anyways.
Mm-hmm.
That makes sense? So kind of two different ways we can loop through all the elements in our list. Now, let's do something interesting here we're out at 55, right?
Yeah.
All right, let's do something interesting in our last couple of minutes here. And then I'll, of course, give you an impossible assignment over Easter break.
Really?
It depends how well you participate in the last 5 minutes. It's like, everybody focus! All right, so we're going to write a quick function that takes a list in as a parameter. And actually, let's not even write the function. Let's just, we'll just put it right underneath here. So I'm going to go ahead and... what we want to do is we want to remove all the 10s. Okay? So I'm just going to say we're going to create a val to remove, and we'll set this guy equal to 10. I want to go through my list, and I want to remove anything that is a 10 from the list. No, just a 10. Anytime I see a 10, remove it. I have a list filled up with numbers between 0 and 10. I want to go through that list after the fact, and I want to get rid of all the 10s. Just dump anything that's a 10, okay? So I'm going to use my normal for loop for I in range of 0 to length of my list. All right, that's kind of our typical pattern for going through any collection of stuff where I need to know the index. And I want to ask the question, is the guy I'm currently looking at a 10? If my list at position I is equivalent to the value I want to remove, which val to remove is equal to 10 because I set it equal to 10 here, right? If it's equal to that guy, I want to remove it. So I'm going to remove it from the list. So I would say my list dot remove I. Does that make sense? But now we've created a problem. When I remove an element from the list becomes one smaller than it used to be. So if I remove bucket 5 out of a 10 bucket list, let's say. All right, so the legal buckets are 0 through 9. So I just removed bucket 5. The next time through, I is going to be equal to 6, correct? But I've actually just made my list one bucket shorter than it used to be. So when I remove an element, don't I need to actually repeat I? I need I to be a smaller value than it was the next time. Otherwise, I'm going to skip an element. I might leave a 10 in there. Okay, let's see if that happens. We'll just do this naturally. Because what's happening here is when I remove bucket 5, what will happen then is the actual bucket 6 will become the new bucket 5. That make sense? But my I moves on to bucket 6, so I'm never going to look at that bucket 5. I'm jumping it.
You'd have to have it repeat.
I have to have it. When I remove something, I got to go and do that pass again on that value. All right, so we want to. We'll just do it like this. We won't modify I at all. So we should have at least a chance. Am I printing after this? I am not. So let me print my list here at the end. And let me also just do a print. I'm just going to print like that because if you notice out here, notice how they're all strung together. That's because we're doing the end equals the space, where print naturally does a carriage return. So I don't have a carriage return in here after any of my stuff. That's why it ended here, but picked up right where it left off on the same line. Mm-hmm. So this will kick it down to the next line, so I see my final print below everything. X is not in list.
Maybe it did the thing and it was pulling from the final number.
No. I think. So we know we have 100 elements. Mm-hmm. If I say remove 15, yeah, it says that guy's not in the list. But if I said remove 10 before, it only removed the 10th element, which was not a 10.
Doesn't the remove function move the first value?
Well, that's what I was thinking.
Because I think pop moves the index that's in place.
Here, what we're going to do here, we're going to say, look at remove much more closely. Maybe remove is doing what I originally advertised it was doing. Instead of removing bucket 10, but I thought we looked at it remove bucket 10 rather than rush because we're out of time anyways. Let's look at remove more closely when we come back on. Now, we don't meet on Monday, correct? Classes that start after 4 p.m. meet on Monday. So the next time I'll see you is on Wednesday. I will probably put up some Bible homework. I'll actually try to put it up today, and I'll make it due like Sunday of the following week, not this Sunday, but a week from Sunday, a week from Easter Sunday, in case you want to work on it early since I won't see you until Wednesday. All right? There was not Bible homework this week. Or last week. Either week. Yeah. All right. Don't forget to post on Slack if you're looking for a study group. That's your homework assignment. We got 7 weeks to get everybody's grade back in order who didn't do well in the exam. So take it seriously. Get some new buddies. Make some friends. Blah, blah, blah. All right? And I can try to help play matchmaker. So let me know. Let me know if you can't find a group. I will introduce you to somebody. Force you into their lives.
Of course.
So,